Today we're going to talk about our last section. Our last section is section 10.5, and we're going to be talking about dividing polynomials. So before we get into dividing polynomials, we have one last exponent rule that we need to talk about. This is not an exponent rule that we talked about in our first section. Okay. In our first section, we did have a product rule. A product rule told us that when we were multiplying terms that had the same bases, that we would end up adding our exponents. Well, now we're doing the reverse. So instead of multiplying, we're dividing. Instead of adding our exponents, well, now we're going to subtract our exponents. Right? So when we're dividing a number or variable with the same base, right, we're going to subtract our exponents without actually changing our base that we have. So the reason that this happens, just kind of looking at these examples that we have here, is because what we're doing, if we think about these and we write these out as exponential expressions in expanded form, right? We see we have a bunch of 3's or a bunch of x's, and then as we go through and we cancel stuff out, right, that's going to give us how many we have left. And it looks like there's one extra one up there. There were 8 to begin with, so that should be 7. Right? Same thing is true here. We cancel out 4 from each, right, and we're left with x squared. So our quotient rule has to do with canceling out like terms in our numerator and denominator. As we're going through and doing these, all of the problems that we're going to see in this section, our larger power of our variable is going to be on top. So we're always going to end up with a positive number as we're subtracting. This is not always the case. You'll kind of run into that in more detail next semester when you take Math 95. But for us, we're going to keep it pretty simple. And if we're thinking about our quotient rule, we're just going to want to do a simple subtraction. All right, so let's use our quotient rule to go through and work through some of these dividing. Right. Y to the 10th divided by y squared. Well, we subtract. 10 minus 2 gives us 8. W to the 7th divided by w to the 6th. We subtract, we get w to the 1st. Again, if you want to put that 1 in there as an exponent, you can. In order to make it look a little bit nicer, we generally leave it off. However, it's the same thing. Right, so for C, x to the 5th divided by x to the 3rd. We subtract, we get x squared. Q to the 7th divided by q to the 1st. Again, if you want to, feel free to throw an invisible 1 in there. 7 minus 1 gives us 6. X cubed divided by x cubed. Notice that we have the exact same thing in our numerator and denominator. Right? Exact same thing in our numerator and denominator will cancel out as a fraction to 1. Or if we use our quotient rule, right, we get x to the 0. And remember, going back to the last section, that x to the 0 is also 1. For f, c to the 5th divided by c to the 0. We can think about this again in different ways. 5 minus 0 is still 5, or anything divided by 1 is still itself. Right? So thinking back to our zero power rule from section 10.1, right, before we explain this, right, that y, anything raised to the 0 power is 1 because it was 0 factors of whatever we were looking at. Right? But now we can say, using example E, well, x to the 3rd divided by x to the 3rd equals x to the 0 using our quotient rule. Right? And x to the 3rd over x to the 3rd, right, just reduces to 1 using what we know about fractions. Right? So x to the 0 and 1 must be equal. So just another explanation of where we got that original value of 1 from back in section 10.1. Right? So we could use our quotient rule or we could use fractions. Right? But going back to this example, the key thing that we're thinking about here, we are subtracting exponents. When we're using our quotient rule, we are subtracting exponents.